morning, doctor. Today we're going to present our project on handwritten digit classification problem. We are trying to build a model that accurately predicts and classifies handwritten digits. In this presentation, we will go through objective algorithms and tools we used, our experimental setup, and results we finally achieved. Our objective in project. This project had several objectives that we aimed to achieve. The first one was to apply the knowledge and skills we acquired during the course to a practical problem. The second one was to use different neural networks to achieve a prediction or high level accuracy over a classification problem. And additionally, we aim to improve the model's performance using different regularization techniques like early stopping, early regularization, and dropouts. Finally, we wanted to apply machine learning concepts to a real life scenario by building a practical application, specifically a website that takes images as input and it takes image and determines the corresponding digits using a trained model. Algorithms and tools we used different neural networks, and to implement this we used Python programming language, we used TensorFlow and scalar libraries, and we also used Google Colab, which provided with a cloud-based Jupyter notebook environment that we can collaborate. Can we both work on the same data and environment? And data sources and pre-processing techniques we used list database. It has thousands of handwritten digit images, and before feeding the data to our models we applied several pre-processing techniques. The first one was PCA. We used principal component analysis for dimensionality reduction, canny edge detection for feature extraction, also thresholding for image segmentation, and finally Gaussian filtering for noise reduction. These techniques helped us to extract meaningful features and reduce the noise in the image and improve our model's ability to make accurate predictions. Our experimental setup: for the first experiment we used a sequential model, a very simple sequential model. It has a single dense layer, and this dense layer had 10 units, and we used softmax activation function. It served as a baseline and it provided us an 87% accuracy. On the second experiment we used the same sequence but multiple layers of dense network, and here we used 512, 128 and 32 units respectively. And here we didn't want to overfit our model with multiple layers, so we used different regularization techniques like dropout, L2 regularization, to not to overfit our system. So after this we finally achieved 95% accuracy, and we used three sigmoid layers and one softmax layer at the end. And our result, the comparison between the first and third model clearly demonstrates the effectiveness of our modification. We achieved 95%. We increased from 87 to 95. This enhancement indicates the utilization of different techniques, neural networks, and deep level of neural networks and additional layers can apply, and applying regularization can improve our model's performance. Overall, our project shows the power of neural networks and its accuracy to classify handwritten digits. And let's go to demonstration.